Okay, let's get after this 5.1 mastery check over arc length and area of a sector. So we're looking at question 1. It tells us the sector of a circle shown at left has central angle NOP with a measure of 2.1 radians. The original circle has a diameter of 8. Okay, I know if I'm talking about these type of problems, the radius is really what I need. And so if the diameter is 8, the radius is 4. What is the area of the sector? All right, to solve a problem like this, I need to have and set up two proportions. The first one I'll set up has to do with the area of the sector because that's what I'm looking for. Again, I'm looking for the piece over the whole, the area of the sector over the area of the entire circle, which is pi r squared. Pi times a radius of 4 squared. We'll set that equal to a second proportion. They gave us information about the angle measure, and so I know the piece is 2.1 radians over the whole, which would be 2 pi radians. Okay, now I can solve for x. These pi's can cancel out. Cool. Let's cross multiply. So I get 2x is equal to 16 times 2.1, which is 33.6, divided by 2. X is 16.8. There you have it. Number 1 is C. All right, let's move on to number 2. In the figure at left, point C is at the center of a circle. Line segment AC is 6. That's our radius. And angle BCE is 2 pi thirds radians. 2 pi over 3 radians. What is the length of arc BDE? Okay. Again, we're looking for an arc length, so that's going to be my first proportion. I'm looking for the piece BDE over the entire arc length, the circumference of my circle, which is 2 pi r. 2 pi times radius of 6. And it gave us information, again, about an angle measure. And so the piece is 2 pi over 3. Over the whole, again, is 2 pi. Okay. 2 pi in my denominator here can cancel out with 2 pi denominator on my proportion on the right. And so when I cross multiply, I get x is equal to, looks like 12 pi over 3, 4 pi. So that's B. Okay. Number 3. The circle shown at left has its center at point F. Line segment FG is a radius, of course. The measure of obtuse angle EFG is 4.7 radians, and the area of the sector is 23,500. What is the length of the radius of the circle? Okay. So this is a new situation for us. We've been solving for arc length or area of a sector or angle measure. We've never really had to solve for radius. And so we need to set up two proportions, both of which are going to have radius in them, as we know. And so the first one I'm going to set up has to do with my angle measure, because that's some information that they gave us. I know that the piece 4.7 radians over the whole, 2 pi radians, is equal to my area, 23,500, over the whole area, which is pi r squared. All right, and of course, when we were talking about angle measure, that proportion actually does not have the radius involved in it, so that makes it a little bit easier for us. Just one r we have to worry about. I'm going to cancel out these 2 pi's and cross multiply just like I've been doing for each of the first two problems. 4.7 r squared is equal to, what is that, 47,000? That means r squared to 47,000 divided by 4.7 is 10,000. Square root both sides. We get r is equal to 100. So 100 is what we'd fill in here. Question number 4. In the figure at the right, point C is the center of the circle and angle BCD has measured 80 degrees. What fraction of the area of the circle is the area of the shaded region? Well, I know, like, the whole reason we've been able to solve these problems to this point is because we know that the proportion of an angle of this sector here over the entire angle is going to be equivalent to the proportion of the area of this sector over the area of the entire circle. And so really what it's looking for is, okay, what proportion is 80 degrees out of 360 degrees, which is the degrees in an entire revolution around a circle. Those zeros cancel out. 8/36, that reduces to what, 2/9? There you go. 2/9 is that proportion. Or fraction, excuse me. Last problem. A circle of radius has a radius of 2 inches. Might as well draw it, okay. It has a radius of 2 inches, an essential angle that measures 6 radians. We'll just say this is 6 radians. What is the length in inches of the arc that is intercepted by the central angle? So it's asking us for this arc length. Well, there we're going to do just like we've been doing. Piece arc length over the entire circumference, 2 pi r, r is 2, is equal to 6 radians over 2 pi radians. 2 pi's cancel out. X is equal to 12. So we'd fill in 12 here, and that is your 5.1 mastery check.